Today, we are going to do something completely different, yet somehow the same. I want us to explore Kubernetes, but not in the way I usually do. Today, I want to demystify how we should define stuff and why some of the commonly used tools might not be the best choice. I want to talk about resources, custom resource definitions, operators, and a few other similar, less known things. Let's start with custom resource definitions, or CRDs. Kubernetes is first and foremost an extensible API. Let that sink in for a second. That means that Kubernetes was not designed to be a thingy that runs containers, at least not exclusively. Or to be more precise, that's true since version 1.7 of Kubernetes, when custom resource definitions, or CRDs, were introduced. Since then, if not before, we can say that Kubernetes is designed to manage whatever and however we want to manage. So, what are Kubernetes CRDs, or custom resource definitions? A simple version is that Kubernetes CRDs are a way to extend Kubernetes API. Now, you might be asking, why would we want to extend Kubernetes API? Well, and this might come as a shocker, Kubernetes itself, the one that comes out of the box, is very, very, very basic. It does not do much. Now you might say, hey, that's not true. It does a lot of things. And you would be right. You can say that we can use it to define deployments which are going to create replica sets, which are going to create pods, and our containers are running in those pods. And that alone is a lot. And it is. You can say that we can use it to define services and ingresses that allow us to access those containers, those pods. Or you can say, hey, Kubernetes is awesome because it allows us to attach external storage into our applications packaged as containers, or container images to be more precise. You would be right on all those statements, partially at least. To begin with, all those things that I named and others that come out of the box in Kubernetes are still very basic. Networking, for example, the one that we get through services, is not doing much, is not really advanced, it's very, very, very basic. Moreover, there is no storage baked into Kubernetes. There is storage interface that can be extended with implementations, but that might not be obvious if you're running managed Kubernetes cluster. What does matter is that storage is not there either. We need to add it to Kubernetes unless we use a third-party provider or service provider that did that for us. So even storage is not there. What I'm really trying to say is that yes, Kubernetes is doing a lot of things, especially if we compare it to what we had in the past. Yet we can do so much more. And to do that so much more, we need to extend Kubernetes. We'll make a very quick break to thank Cast AI for sponsoring this video. Cast AI is likely one of the best and fastest autoscalers on the market. It works with Kubernetes, and apart from normal servers, it also supports GPU nodes. So those working with AI and ML are covered, very well covered. And if you want to save on your bills, it works with spot instances as well. It's a wide-reaching automation platform for Kubernetes that automates cost optimization and removes the need for you to manually fiddle with resources. Try it out for free. Now, let's get back to the video. Anyways, we got CRDs long time ago that allow us just that. They allow us to extend Kubernetes with something. For example, there is no such a thing as application entity in a Kubernetes cluster. There is a collection of building blocks like deployments, ingresses, services, but there is no such a thing as application. We can use those building blocks, but if we want to have something that resembles application, at least from the end user perspective, we need to add that ourselves. Or as an alternative, we can install a third-party solution that will bring us something that resembles an application. Similarly, there is no such a thing as a database in Kubernetes. If we would like to run databases in Kubernetes, one option is to work with those building blocks, which are not really great or especially complex, we can define CRDs ourselves, or we can install third-party solutions like, for example, cloud-native Postgres or CMP. Now, before you say, that's okay, I can live with those building blocks, let me ask you a question related to, let's say, databases. Will those building blocks give you a possibility and feature, an option to define when your database will be backed up, when it will be restored and how it will be restored, how to replicate data between replicas of the database and so on and so forth? No, there is no such a thing. You cannot do it, at least not in a Kubernetes native way, without extending it through custom resource definitions. We can say the same thing for quite a few other solutions. For almost all Kubernetes native applications, that would be Crossplane, kubevela, Kubernetes operator for Prometheus, KubeVirt, and quite a few others. If you're already using Kubernetes, you already probably extended it, whether you know it or no. It's enough to install almost any third-party solution for Kubernetes, and you're extending your cluster with custom resource definitions. And those custom resource definitions define how we can do something, how we can create Argo CD application, how we can create a database using Crossplane, how we can create virtual machines. So the short version is that custom resource definitions enable us to define what something is in Kubernetes. Now, with that out of the way, the important thing to note is that custom resource definitions, or even resource definitions that are baked in Kubernetes, are not doing much by themselves. They're actually doing nothing. They're just the way to extend Kubernetes API without performing any actual work. Hence, CRDs are useless by themselves. What they need are controllers. When we instruct Kubernetes API to create a resource or custom resource, all that we're doing is publishing an event saying, hey, somebody created this resource, this thingy, whatever that is. The event essentially says, hey, I have this resource. That's it. That's all it does. Actually, that is not all it's doing, but for the sake of this story, you can consider that being the only thing that we get when we create a resource. So messages like, hey, I got this new resource, or this resource was modified, or this resource was deleted are just events. And something needs to listen for those events and do something about it. And that is where controllers come in. Swoop in. Controllers are essentially processes that listen for events related to specific resources or custom resources and then do something when those events are published. So if Kubernetes API creates an event saying, hey, somebody wants to create or manage a database, there is one or more controllers that kick in and say, hey, that's me. I would like to do something with the database. If that would be cloud-native Postgres or CMPG, it would catch that event and create whatever needs to be created for that database to be running and run successfully and be managed and do whatever needs to be done for our databases inside Kubernetes clusters. On the other hand, if that would be Crossplane with a controller created through Crossplane compositions, it would do something similar, meaning it would create whatever needs to be created to manage databases, but in that specific case, in a hyperscaler like in Google Cloud or AWS or Azure. Heck, you could have multiple controllers, and you often do, listening for the same events and then doing one thing or the other. What those things, those controllers do can be anything. It really depends on controllers. And that means that Kubernetes can be extended to manage anything or everything or nothing. It could be managing virtual machines. It could be managing cloud resources in AWS, or it could be ordering pizzas. Actually, there is a controller for ordering pizzas. Now, please note that the story is the same, no matter whether we are talking about controllers related to custom resource definitions or CRDs, or controllers that are already baked inside Kubernetes itself. Controllers listen for events and then do something. Actually, some resource definitions that are baked into Kubernetes, like networking, do not even come with controllers. We need to pick which controllers will fulfill networking tasks. So when we create a service in a Kubernetes cluster that comes out of the box, there is no networking. But if we install Cilium that understands events related to services, then something is happening. Then we have networking between our applications. So, long story short, controllers are processes that do the actual work related or initiated through events, and those events are coming from us creating resources or custom resources that are fulfilling the schema based on custom resource definitions or resource definitions. Now, there are also operators, but operators is just a pattern that defines how controllers should be created. Not every controller is an operator because operators need to follow specific patterns, but every operator is a controller. So operators are just a pattern how to create controllers, and probably the most important part of that pattern is that they need to implement control loops. Still, for this story, all that should not matter. You can think of operators and controllers as the same thing. They manage life cycles of things defined as custom resources. And now comes the interesting part, or to be more precise, the answer to a question that I get quite frequently. It goes something like this. Victor, you talk often about creating operators and controllers and CRDs and all that stuff, and we can be writing it ourselves or we can get them to third parties applications or services. And I would like to know whether I should do that or I should keep using Helm or Customize or JSONnet or YTT or whatever I'm using to define what something is. So CRDs and controllers on one hand or Helm and similar tools on the other. Which ones should we choose? The short answer is that one does not exclude the other. Kubernetes expects us to communicate with it by sending requests to its API, and those requests must be in form of YAML or JSONnet. There is no way around it. Kubernetes API only understands YAML and JSON. Did I say JSONnet? No, JSON. So YAML and JSON. We can write that YAML either directly or we can use some other tools like Helm to help us write that YAML, which sounds strange, right? Now, the important thing is that it is always YAML or JSON. Always. It must be YAML or JSON. We cannot send Helm chart to Kubernetes. We cannot tell Kubernetes, here's a Helm chart, do something with it. No, we need to communicate with it in form of YAML or JSON. So what is happening when we execute commands like Helm install, we are getting YAML. We are converting templates, Helm templates into YAML, and that YAML is sent to Kubernetes API. It's always YAML. Now, whether that YAML represents a definition of a resource or definition of a custom resource does not matter. It's all the same to Kubernetes. If that resource is acceptable, or to be more precise, if there is a schema for that resource, if it complies to a specific schema, it's good to go. And that schema is either what is baked into Kubernetes or what we extend it with, and that's CRDs. So CRDs and operators and controllers are a way to extend capabilities of Kubernetes, and Helm or Customize or JSONnet or YTT or any other tool that you use to define what you want to send to Kubernetes are just shortcuts. They are just templates or overlays that get converted into that YAML. One does not exclude the other. However, using CRDs might result in less of a need to have something like Helm. So you can use Helm, but you might not want to. Let me explain. We use templating solutions like Helm to define all the variations of all the resources that constitute something, let's say an application. And those variations are many. We might have to change every once in a while the tag of an image or a host or the number of replicas and so on and so forth. Now, when we use Kubernetes building blocks like services and ingresses and deployments and stateful sets and so on and so forth, we have a lot of those resources to manage. Hence, we need something to help us with that. Otherwise, we would end up with thousands of lines of YAML. And that's why we have templating through Helm and similar solutions. And now comes the important part. We are generating all those resources, all those building blocks on the client side. Helm is a client-side tool. When we execute Helm install from a terminal, let's say, and I consider terminal like a client, then we are generating the end results, the final manifests that are combination of all those resources and then sending it to Kube API. So most of the action is happening on a terminal or in a pipeline or anywhere outside before Kubernetes API. However, if we create our own CRDs and our own controllers, or if we install third-party solutions like there are many, Knative, for example, then most of the action is not happening before something reaches Kubernetes API, but inside the cluster. Controllers in those cases do most of the heavy lifting. They're responsible for creating all those building blocks, all those pods and deployments and services and ingresses inside Kubernetes clusters. Essentially, what Helm is doing on client side, before something reaches Kubernetes API, controllers are doing on server side, inside clusters. So you can think of a controller that defines how a database should be managed is equivalent to Helm templates, except that it's doing the work inside the cluster. And that means that we, humans, do not need to define all those building blocks. We do not need to deal with all those details, with all those low-level resources ourselves, because clusters are doing the work for us. And that makes things much simpler. We can define 10, 20, 30 lines of YAML that define some custom resource based on custom resource definition instead of hundreds or thousands of lines of YAML that define all the low-level details of that something. What we end up defining is much simpler, shorter YAML, less of everything on our side, on client side, and that means that there is less need for templating. If it's 10 lines, then a simple YAML file should be enough. There is no need for Helm. If it's more complicated, slightly more complicated or slightly more complex, then we might be still better off with Kustomize because, hey, it's not 20 lines of YAML, but it's 50. But do we need templating for that? Probably not. In other words, if complexity is moved away from terminals and pipelines and wherever we are doing things into the clusters, then the complexity of what we need to define before we reach Kubernetes API is much lower, hence lower need for templating. Complicated thing becomes a simple YAML file. So let me go back to the initial question. Should you be creating CRDs and controllers and so on and so forth? And the simple answer is yes, you probably should. CRDs are a way to extend Kubernetes API with new schemas, and through those new schemas, allow controllers to do the work that we normally do before we get to Kubernetes. Controllers are about delegating work from humans to machines. More importantly, CRDs and controllers are Kubernetes native way to do things. Helm is not Kubernetes native way to do things. Controllers and CRDs are. That does not mean that we do not need Helm. We still need to generate that YAML somehow, but we do not necessarily need to have it as complex as we do. If you have a backend application, define a CRD and a controller that will manage and create and delete and do whatever needs to be done with a backend application. If you have a front-end application, well, again, CRD, controllers do the work inside the clusters. If you need a database, well, again, the same thing. The only question you need to ask yourself is whether you should create those definitions and controllers, or you should use some third-party solution for that, like Knative, KubeVirt, Cloud Native, Postgres, and so on and so forth. And if you do that, many of the things will be so much easier. For end users, it will be easier to define something like, hey, my application, how do I define my application? Well, those 10 lines of YAML that contain whatever is the host or the type of the application, whatever you need to define without going into low-level details. Observability will become easier. Logging, monitoring, everything will become so much easier if you follow what Kubernetes prescribes you to follow, and what Kubernetes wants you to do is to extend it. But there's a word of warning I must say in advance, no, at the end of this video, Do not write yourself controllers. In most cases, there are tools that will enable you to do that. There is Kubewell, there is Crossplane, a project I'm very vested in. There are many, many others. I will not suggest which one to use, but remember, there are easy ways to create custom resource definitions and controllers that will do what you want them to do, that will extend your Kubernetes clusters to a reasonable level, to a useful level, to a usable level. All in all, know this. Custom resource definitions and controllers are a bedrock of Kubernetes. They're probably the most important feature of Kubernetes. Kubernetes is an extensible API designed to be whatever you want it to be. Embrace it, use it as such, and you will see how things change drastically. Do not be afraid to do what Kubernetes eventually suggests you to do. Do not be stuck in the past. Do not try to apply the logic you were doing or using or applying before Kubernetes with Kubernetes. Thank you so much for watching. See you next time. Cheers.